All right, let's jump into market power and monopoly. Today we'll work on profit maximization. Here are the steps that we'll follow. We'll find the inverse demand curve given some direct demand function. We'll derive marginal revenue, set marginal revenue equal marginal cost to find Q star, the profit maximizing quantity, and then we'll find P star, the profit maximizing price, by plugging Q star into the inverse demand curve. After that, we will draw the graph, shade deadweight loss, shade consumer surplus, shade producer surplus, and then we'll do a small comparison for monopoly and perfect competition. We'll compare consumer surplus and producer surplus graphically, right? So let's jump in. Here is the direct demand function that we have. Q equal 200 minus 0.2p, and marginal cost is 200. Okay, so we need to find the inverse demand, and here is how we go about it. To find the inverse demand, you just make P the subject, right? So you're going to write 200 minus Q and take or add 0.2p to both sides. So that's my 0.2p. And then you divide by 0.2 such that you have your P equal, well, 200 divided by 0.2 is 1,000. 1 divided by 0.2, or Q divided by 0.2, is 5Q. And so minus 5Q. And so that P equal 1,000 minus 5Q is our inverse demand. From that, we need to derive the marginal revenue. From previous videos, we know that the marginal revenue shares the same intercept as the inverse demand curve. And so MR, marginal revenue, equal 1,000. And the marginal revenue slope is twice that of the inverse demand slope, and so that's 5 times 2, and that will be minus 10Q. That's the marginal revenue. From here, we will set marginal revenue equal marginal cost to calculate Q star. Okay, marginal revenue is equal to 1,000 minus 10Q. We want to set that equal to the marginal cost, right? Marginal cost is 200, and so I'll use my eraser to get rid of that other side. Okay, from here we want to make Q the subject. To make Q the subject, I can, how about we subtract 200 from both sides, right? So 1,000 minus 200, and we add 10Q to both sides. 10Q, like this. This will be 800. On the left hand side, you will have 800 equal to 10Q on the right hand side. Divide through by 10 so that your Q is equal to 800. Very good. 80, not 800. The Q is 80. Q is 80. And I'm going to write all that. I just canceled out. Right? So 800 divided by 10 is 80. Q star is 80. Okay, we have to plug Q star back into the inverse demand to get our P star. So let me move the math we've just worked on to one side so we have some space to write. Very good. How about I use a different color? How about we use green? Okay, from here we are going to plug that Q star equal 80 into our inverse demand so that we can get our P star. Well, inverse demand from step 1 is P equal 1,000 minus 5Q. Okay, Q was 80. And so this will be P equal 1000 minus 400. Okay, and so P equals $600. There we go. So our Q star is 80 and our P star is 600. Can we draw this? Yes, we can. We can draw it. How about we use blue for the demand curve, for the inverse demand curve? And the inverse demand curve is P equal 1000 minus 5Q. And so, well, when Q is 0, let me write that better. When Q is 0, our P is 1000, right? So up here, we'll have 1000. And the other way, when P is 0, Q will be 1000 divided by 5, so 200, right? So our 200 is here. We are going to connect the two. Let's try to use this ruler. Okay. All right. We have our inverse demand curve drawn, right? The next is we want to draw our marginal revenue, and there is a way to do it. The marginal revenue will cross the Q axis, so let's write that Q and P up here will cross the Q axis exactly at Q equals 100. Please see the previous video to understand why that is true. Okay, let's connect these two. Now, the marginal revenue shares the same intercept with the demand curve, and the marginal revenue has twice the slope of the demand curve, as we saw earlier on. And so, whoops. So down here is 100. All right. Marginal revenue, and that is demand, inverse demand. Let's draw the marginal cost in red. Okay, so marginal cost is 200, and that is just this constant line right here. Marginal cost is 200. Are we done? We are almost there. We are almost there. So, well, profit maximization for the monopoly is such that the monopoly will set its profit maximizing quantity where marginal cost and marginal revenue cross each other, and that's right here, right? So the Q star there, which is what we just calculated, Q star equal 80. So we are looking at the intersection between the marginal cost line and the marginal revenue line, and we are deducing that along the Q axis, Q star is equal to 80, because we projected a vertical line from the intersection between marginal revenue and marginal cost to touch the quantity axis. Now we can project that intersection up to touch the demand curve and read that off the price axis, such that that is exactly where our P star equals $600. Okay, so we've just graphed our price, our inverse demand curve, our marginal revenue, which was also 1000 minus 10Q. We just graphed these two. We graphed marginal cost equal 200, We graphed these three curves and we saw where the marginal revenue intersects with the marginal cost. We projected a vertical line through that intersection. The vertical line where it crosses the quantity axis, we read that off as Q star equal 80. And the vertical line where it touches the demand curve, we read that off the price axis and find P star equals 600. That's what we've just done. Okay, the next thing that we're going to do is shade. Right, we want to shade the deadweight loss. And to shade, I'm going to try to, well, let's use black to shade the deadweight loss. Right, this area here, the deadweight loss is that black shaded area. Good. What about producer surplus? And what about consumer surplus? Well, let's change. Let's get yellow for consumer surplus. Consumer surplus will be the area below the demand curve but above the price 600, and that is right here. Right, so let's label that really fast. That is the consumer surplus, CS. Well, what about producer surplus? Producer surplus let's find a different color for this. How about green? Producer surplus is the area that is below the price but above the marginal cost curve, right? So let's shade that. I hope I have, yeah, I do have the right color. That's the shaded green area, the green shaded area. Right, so let's label that producer surplus. Producer surplus is the area below the price 600 but above the marginal cost curve. Okay, that's a pretty colorful graph, eh? The last thing that we're going to work on is compare monopoly and perfect competition. And so to get that point across, how about I draw for us a different graph, as we already have some things on the other graph. So we have price, we have quantity, and let's draw a demand curve. Let's use blue. Let's draw the demand curve. I'm trying to connect these two endpoints here. Okay, so that's the demand curve. That's the demand curve. That's a perfect looking demand curve, isn't it? Now, let's draw the marginal revenue. Marginal revenue shares the same intercept as the demand curve, and like so. So let's use blue as well. That way I don't run out of, whoops. That way I don't run out of color. Now label this as the marginal revenue. I will label this demand curve as just, this inverse demand curve as just demand. And I will edit my y-axis because I just erased it accidentally. Okay. We need a marginal cost curve. If we had a horizontal line, a constant marginal cost, we'll have MC here. Now, I want you to think back to perfect competition. In perfect competition, we said that, well, price is determined in the market where the supply curve or the marginal cost curve intersects the demand curve, right? That's right here. That's right here. That's right here. So I've just shaded that point where the marginal cost curve crosses the demand curve. I've just noted that intersection with a black dot, a big black dot. Okay, so that will be the price for perfect competition PC, and if I project that intersection between the marginal cost curve and the demand curve down to touch the Q-axis, that will be the quantity PC. See that? I hope you do. Okay. So what we have on here is the price in perfect competition and the quantity in perfect competition, because in perfect competition the price is determined in the market where the supply or marginal cost curve intersects the demand curve. We have it down. Good. Oops. Next, for the monopoly will set marginal revenue equal marginal cost, and let's use the green, and that will happen where the marginal cost curve intersects the marginal revenue curve at this green dot. And when I project that green dot or draw a vertical line through that green dot, I'm going to get this. I'm going to get quantity M for monopoly, and I'm going to get up here price M, superscript M for monopoly again. Okay, so how about I label the various areas on here, 3 areas that we are interested in. This area here, area A, this area here, pardon me, area here, area B, and here, area C. What's happening here? Well, we have monopoly versus perfect competition. We are interested in producer surplus, and we're interested in consumer surplus. Well, consumer surplus in the perfect competition scenario will be areas A, B, C. So areas perfect competition for consumer surplus areas A plus areas A, B, and C. So a sum of those areas will give us the consumer surplus under perfect competition. Now, from our graph earlier on, you saw that consumer surplus was the shaded yellow area above price equals 600. Well, a version of that is just area A here under monopoly. Now, let's work on producer surplus. Producer surplus under perfect competition will be the area that's below the price PC but above the marginal cost. Well, that's 0. That's 0. And so under perfect competition, producer surplus is 0. It's 0 because there is no area that's under price PC and above marginal cost, right? Because the marginal cost curve is horizontal. That's why producer surplus is 0 under perfect competition. Okay, for monopoly, if you remember, that area is for producer surplus is area B. Now, deadweight loss. There is no deadweight loss in perfect competition. Deadweight loss is 0. But then, the deadweight loss in monopoly is area C. You see? So, there are losers and there are winners in the different markets. You see? Under monopoly, Producer surplus is area B. Under perfect competition, there is no producer surplus when you have a horizontal marginal cost. Consumer surplus under monopoly is area A. Under perfect competition, that area gets larger. And then for deadweight loss under monopoly, that's area C. In perfect competition, that's 0. I hope you see that the monopolist always produces quantities that are less than the quantities that the perfect competition produces, because QM is less than QPC. So the monopoly produces less. What else do we observe? We observe that the monopoly price is bigger than the perfect competition price. Yes, the monopoly always jacks the price up. On that note, we will call it done. Thank you for a good, sort of class. If you have questions, please email them to me. If you are a student, send them to me, or come to office hours, right? Or email them. But if you're in you live in the YouTube streets, please leave us a comment. It's always nice for you to hype the video. I'm hearing you can hype videos. You can. I didn't know about that. I just learned about that. Now you could like the video. That would be great. And definitely subscribe. Okay, so Dr. T is out.